Hello and welcome to CS101 Introduction to Computer Science. This is class 2 and we're going to talk about hardware today. So where are computers today? You will find that computers are not only in your desktops and laptops but also in your smartphones, small devices, maybe even your car, in what is called the Internet of Things, and basically almost all electronic devices. Anything that has a processor, some software running on it, would technically qualify as a computer, actually. And there are certain core parts that all computers have. They basically refer to bits and bytes. This is how data is represented in a computer. There is a processor, which is the brains of the computer. We're going to talk about all this in just a few seconds. There's memory. There's both short-term and long-term memory to store data. There's input. How do you send inputs and commands to your computer? And output. How you view the response that your computer gives you. Let's talk about bits first, right? So what is a bit? It is the most fundamental data structure in a computer. A bit is actually at the fundamental level, it's just a 0 or a 1. So if you think about it, it only has two states. It's either a 0 or 1. Think of it as a light bulb, similar to a light bulb, which is either on or off. A bit is similar. It's 0, which is off, or 1, which is on. So you might be wondering, what is the functionality of a bit? How do computers use bits? But actually, a bit by itself is not useful. It's a 0 or a 1. It's an on and or off switch, right? But through multiple bits, you can represent complex states. You can store pictures, videos. All of these are stored in the computer in the form of bits. So computers process real-world information that is translated into bits. So processors process bits. Actually, they process bytes. We'll talk about that in the next slide. And memory and hard drives store bits. So at the fundamental level, when you're looking at a computer, it's stored data as bits. What are bytes? So a byte is 8 bits. That's really what it is. 1 byte is 8 bits. It's a series of 8 bits. You might have heard about a kilobyte, megabyte, gigabyte, terabyte. So these are just scales of bytes in orders of 1,000. A kilobyte is 1,000 bytes, a megabyte is 1,000 kilobytes, a gigabyte is 1,000 megabytes, and a terabyte is 1,000 gigabytes. So you have scales of 1,000. When you use numbers, it's 1,000, million, billion, trillion. And when you talk about space in computers, it's a byte, kilobyte, megabyte, gigabyte, terabyte. And then it goes on exabyte, petabyte, and so on. But we won't talk about those here. Actually, if you talk to a computer purist, right, they will say a kilobyte is not actually 1,000 bytes, it's 1,024 bytes, and a megabyte is 1,024 kilobytes. The reason is because computers store data in powers of 2, so 2 power 10 is 1,024, which is the closest to 1,000. So internally, computers measure these things in multiples of 1,024 rather than 1,000, but it's a semantic difference. It doesn't really matter whether you think of it as 1,000 bytes or 1,024 bytes, but obviously if you were to take an exam, they might ask you to be very precise about it, but this is kind of how the concepts relate. And small, like I mentioned in the previous slide, there's a caveat. Processors, memories, and disks usually deal with bytes, not individual bits. They usually take a byte at a time. That's typically the lowest common sort of denominator of storage or processing. They take 1 byte, 4 bytes if it's a 32-bit computer, 8 bytes if it's a 64-bit computer. But the idea is everything stored as bits, but they're grouped together as bytes. So how do computers process bits and bytes? Actually, to a computer, everything is bits and bytes. The keys that you press on a keyboard, mouse movements and clicks, data flowing through the cellular or Wi-Fi network, the graphics that you see on your screen, when you touch your smartphone touchscreen and do something with it, everything traverses the computer from one place to another as bits and bytes. So let's talk about how a computer processes information. At the core of your computer is something known as a processor. Also, this is the brains of your computer. It reads instructions and executes those instructions. And processor instructions are really something very simple. So the code, the software running on it, tells a processor move something from one memory location to another, multiply these two numbers, add these two numbers, write these bytes, to a graphics card. That now those bytes themselves could actually be a video, but it doesn't matter. To a computer, you're telling it write these bytes to a graphics card, and it's going to send that set of bytes to a graphics card, which might display video on your computer. So there's many generations of processors from the 1970s when computers first came into being to current. And today there's two popular processor architectures you might have heard of: the Intel x86 architecture for desktops and laptops, and ARM processors for mobile. Again, we won't talk about this in more detail in this class, but you can look up about processors online. Memory. So instructions and data for computers are stored in memory. The CPU cache, which is in the central processing unit in the processor, is actually the fastest memory. It's right on the CPU. It's very limited in space, and processors use it for really fast caching and execution. You almost never hear about it. This is never advertised because it's in the processor. It can be added or removed, so it's right there. Now, there's another layer of memory called random access memory. It's a very fast layer that's one layer away from the processor. It's typically a few gigabytes of storage these days. And the thing to remember about memory, RAM memory, is that it's cleaned up when a device restarts. So when you shut down and restart a machine, then this memory gets removed. But it's used for very fast storage. When a computer is processing information, it typically reads this from this random access memory. There's also hard disks and flash drives. These are long-term storage. These are slower than RAM, random access memory. But the good thing about these is that it persists data across device restarts. These are typically in the orders of several gigabytes to maybe even a few terabytes. You see hard disks these days that are greater than 1 terabyte in storage space. And typically this is where your files are stored. When you start a smartphone or your computer, this is where the long-term memory, where things are stored, and they get loaded into RAM because RAM is just so much faster and the processor can process data so much faster when it's in RAM. So it's just multiple layers of storage, but RAM, even though it's faster, can't store it across device reboots, whereas your hard disk and flash drives can. So your computer or your smartphone actually has these two layers of memory in it. Just a quick note about hard disks versus SSDs. Hard disk drives used to be the long-term storage for decades. They are being replaced more and more with SSDs, which are solid-state drives, which are becoming popular because they're faster, usually more reliable, they consume less power, and they're less sensitive to being moved around because SSDs are flash-based, flash technology-based, and hard disk drives are mechanical, spinning wheel-based. The caveat is right now, as of 2017, SSDs are typically 4 times more expensive than hard drives, and but smartphones and smaller electronics use flash or SSD technology just because it's smaller, faster, and you can get more speeds, smaller space with these technologies. Typically, desktops and laptops, even today, still use hard disk drives, but I, for one, prefer SSDs just because they're so much faster. A little bit of note on memory terms. You'll often see electronics advertised like this. If you're buying a computer, you will see 6 gigabytes memory, 640 gigs hard drive or flash drive, and a smartphone is 1 GB memory and 32 GB flash drive. What does this mean? It's a surprisingly common question. So does your computer really have 6 gigs or 640 gigs in memory? The answer is that it has both, actually. 6 gigs is 6 GB is the RAM, the faster memory that's used to run programs. This is again the temporary memory that you lose when you restart a computer. 640 GB is the long-term storage. So when you save files, when you save your audio or video or photos or recordings, the data is stored in long-term storage. Now it's stored there but loaded into RAM for your processor to process at a faster speed. So the answer really, it has both types of memory in it. Typically when people talk about memory, it refers to long-term faster RAM, and people talk about storage when they're referring to disk, but your computer really has both. Networking. This is very common to all computers these days. They allow one computer to connect to another, or one smartphone to connect to another smartphone, or your devices to talk to each other, either over a local network. If you're in your house, they're connecting over a local network behind your wireless router, or over the internet. In that case, they connect to other computers that are connected to the internet. There's multiple forms of connection and networking. One is wired connection, where you might have a physical wire going between your router to a computer, your desktop or your laptop typically. There's wireless Wi-Fi, so your devices can be connected over the wireless network, and typically your smartphone and other devices in your house may be connected through a Wi-Fi or wireless signal. And then there's also cellular networks, 3G, 4G, LTE, and there's upcoming 5G standards. These are where you're connected to a cellular tower, which is basically the same signal as your phone. So you have a cell phone where you talk and you text, and you basically use the same cell phone networks provider to get data as well. And you can also use, in some cases, you can use your phone as a hotspot. So not only are you getting data from a cell phone, you can use your mobile device as a hotspot, so that can provide Wi-Fi connectivity to other mobile devices. And in terms of computer input, so you have a whole bunch of ways in which you can interact with your computer. Your keyboard can send keys and keystrokes, a mouse can send clicks and things like that. Output, this is the information the computer sends you. So most likely it's a monitor or display, almost like a TV. It's just higher resolution. So computer monitors are a bit different from TV because they usually have higher resolution and they're meant to be viewed from a closer range, whereas TVs are meant to be viewed from a further distance. But the line is blurring between computer monitors and TVs, and typically you can use one or the other interchangeably. Typically you don't sit right in front of a TV, you can sit right in front of a computer monitor, but the technology lines are blurring. And a touchscreen combines keys, movement, and display, so it's actually both input and output. So this is what you use in your smartphone or tablet. You also have audio speakers, obviously, to get auditory output. You can speak into a microphone. So these are just various ways of input and output to a computer. So now that we've talked about one computer, let's talk about multiple computers. Though many of you may not actually use these in your day-to-day life, let's talk about how these operate. So what are servers? Servers are computers that are used to serve data to users over a network. When you connect to the internet using a browser, or you're using a mobile app that connects to the network and is pulling data from the internet, you're connecting to a server that sits somewhere on the internet or somewhere in the cloud, as people say. We'll talk about cloud computing a bit as well. So you're connecting to that server, which looks somewhat similar to a regular computer, but not directly used by the user. This server, even though it's a computer, it uses a processor, memory, and things like that, is built to handle large volumes of information and data. It's not meant to be used by a user who's tapping away on the keyboard or mouse and viewing a website. It's meant to serve data to a large number of users on the internet. Data centers. Now, we talked about one server or a few servers. Think of a location that has a huge number of servers, right? Like places like Facebook and Google, which are serving billions of users on a daily or monthly basis. So you need a huge number of servers. You need thousands or tens of thousands of computer servers to serve all these users with the data that they are requesting. So these are data centers that are in one location. They're co-located and hence called colos, and they have the servers on a rack or something like that, like you see in this picture here. These are usually co-located for the following reasons. They are less cost if they're in one building. You get economies of scale, better security. You can secure an entire building with these servers. You get faster networking connections and better networking if you have an entire data center that's dedicated to just hosting these computers. So for a whole bunch of reasons, servers are often located in data centers, or colos as they're called, and your browser or mobile app, when you're using it to connect to the internet, is often getting data from servers that are sitting in data centers somewhere in the world. And that is the foundation of internet and large networks. So the internet is basically just computers connecting to each other and exchanging information. And again, when your smartphone is connecting to a server, it's connecting to a server somewhere and getting data. And these computers are all connected, on the user side through wireless cellular or wired Ethernet connections, as we talked about. But there's also much larger network connections on the server side. And when you talk about global distribution, of data and internet, there's large transatlantic continental cables that are often, put underneath the ocean that facilitate cross-continent data transfer. And you can see like a photo of that, how those are laid out here. These go underneath the oceans, and literally companies plumb the ocean's depths to set up these cables that allow internet to be transferred across multiple continents. So that brings us to the end of this class. We started with one single computer. We learned about servers and data centers and how all of these connect to each other through the internet. So whether you use electronic devices or one-day program software and devices, these are kind of the fundamental concepts in how computer hardware works, whether it be one machine or one device, and how you connect to multiple machines and servers and data centers on the internet. So this was hopefully a brief 15-minute introduction to how computer hardware and servers and networking works.